right now. Okay? This is you under the ocean. This is you when you get too close to Jupiter. And this is you when you get too close to a black hole. Scientists used to deny the existence of black holes, but with our ever-expanding knowledge and technology, we found hundreds of black holes in our Milky Way galaxy and other galaxies. Now, we've never actually been to a black hole, but we know of their existence through telescopes and satellites. Webster's dictionary defines a black hole as a region of space where the gravitational field is so strong that radiation, matter, and light cannot escape its pull. Now, a black hole comes to be formed by a dying star. When a star, 25 times the mass of our sun, so you have our sun, then something 25 times the mass of that creates a supernova, which is when the star can no longer sustain itself, the core then collapses in on itself and creates a black hole. Mathematically speaking, anything could be a black hole if you compromised it into a small enough space. And the reason scientists, lots of people love or hate black holes is because they take our law of physics and our law of the universe and they break them down. When it comes to black holes, nothing makes sense. But a black hole is actually not a hole. It is a point. It is an infinitesimally small point known as the singularity. And lots of people have trouble fathoming the reasoning behind how one small point can swallow up entire galaxies, because a black hole doesn't really have anything else to do except wander across the universe, consuming planets and stars and anything that gets in its way. But that's just the formation of black holes. Hypothetically speaking, let's say if you were to travel to a black hole, what would happen? Now, lots of people think that if you were to approach a black hole, you would kind of get swallowed up like a vacuum, kind of like being sucked in and you just wouldn't remain. But the thing is, when it comes to black holes, that's not actually what happens. What happens is, as you're approaching the black hole, you sort of freeze. And from the observer's point of view, you are frozen, and then the light is being sucked off of you, and then you will sort of fade, and that's what it would look like to the observer. I have a video to show, and I think it explains it quite well.
That an observer standing, watching you jump into the hole, would see something quite strange. They wouldn't see you get sucked quickly into the hole. Instead, they would see your approach become slower and slower and slower until you reached a point known as the event horizon. This is a point in space where, once crossed, there's no going back. It is at that point that light can no longer escape. And so to a person watching you fall into the hole, that would be where your journey ended. You would seem almost frozen in space, the light coming off your body becoming increasingly redshifted until you simply faded into nothingness. They would never see you cross the event horizon.
We call the event horizon because it's a place between the edge of the black hole and the outside around it, and it's just a word for separating the areas. So let's say anything could actually become a black hole through something known as Schwarzschild's radius. It means basically a tiny amount of space. So if you took the mass of an object and you compressed it into a tiny amount of space, sort of like if you took the entire Earth and you put it into the size of a peanut, that would create a black hole. If I took you or anyone in here, compressed you into a really tiny amount of space known as Schwarzschild radius, you could become a black hole. But that video that I showed you was what it looked like to an observer. That's what a person would see if they were watching you go into the black hole. But to you, you would basically fall into your inevitable death, but you would go through something, you would go through something called spaghettification. And it's exactly what it sounds like. You become spaghetti. See, when you're approaching a black hole, let's say if you even got close enough to reach the black hole and you were still alive, spaghettification is because your feet are closer to the center of the black hole and your head is further away. So As your feet approach it, you slowly get stretched out, sort of like taffy being pulled between two forces. And then you would just become this tube of pasta. But if you survive that journey inside the black hole, when you reach the singularity, which is basically another word for we don't know, because singularity takes the laws of physics, time stops in the black hole, it literally stops, and gravity becomes infinite. So if you reached it, you would find a place where reality breaks down. But right now, our technology doesn't have that sort of advancement for us to travel to a black hole. Some scientists believe that we could use them for time travel, sort of like a portal. Because mathematically speaking, if you were to jump into a black hole, the theory is that you would fall straight into a wormhole, and that would kind of be like traveling to another universe. According to Professor Michio Kaku, who is a theoretical physicist, he says that time travel is possible, but not very practical. The material to keep the throat of a wormhole open is something that we cannot produce in our laboratories nowadays, but might be possible for our descendants to do so. And then it would be possible for us to exploit the power of a black hole and use time travel. So one day, if someone comes knocking at your door, claiming to be your great-great-great-great-great-granddaughter, don't slam the door.
All right, Maram, I like the visualization that you had at the beginning as your attention device. I thought that worked pretty effectively. We know what your topic is, and the photos that you're showing us and the GIFs, I think, also do the same sort of thing. I do think that you need to have a clearer statement, though, of what you're going to be saying about the subject, and I didn't really hear a preview. So those are structural things that we've done before, we've talked about, and I think we're kind of missing from the presentation. When you introduce the concepts, though, you do a nice job kind of signposting as you go along. We've got a visual reference about what it is we're talking about at any given point. So that helps a little bit. There is some reference to supporting material in the presentation. I thought that was pretty effective. All the delivery things are solid. You do have to move back and forth a little bit to operate the computer, but that was not a huge distraction. Your gestures and your facial expressions and your eye contact were all very solid. The integration of the visual materials was effective. You were not dependent on notes. Maybe you could project your voice a little bit more and maybe have a little bit more force there, but I thought that there was very good variety when you were speaking to us, and emotional ideas and questions came across effectively by the way you changed your tone while you were speaking. I didn't notice any particular problems with pronunciation, and it flowed very smoothly during the presentation. Again, also no issues on anxiety that I could pick out. The only things that I think are obvious fixes are the organizational issues, and that's about it. Other than that, I thought the presentation material went very well. All right, thank you.